we just talked about the Pythagorean theorem. And so now I want to discuss how we use it to find the distance of points on a coordinate plane. So if I look at this point being the origin on a coordinate plane, and then I mark 1, 2, 3, 4, 5, 6, okay? And I put 2 points on here at 2 and 5. Okay, I know the distance between this point and this point from A to B is 3, because I know that the distance from 5 to 2 is 3. But how do I know that? Well, I know that the distance from the origin to B, so origin to B, minus the distance from the origin to A, which this distance is 5, minus the distance from A to B, the origin to, from origin to A is 2, leaves us with this distance right here of 3. So we know a few things about distance there. But what if I don't know the exact points? What if I just know that I have 2 points out here, x1 and x2? Okay, so I need more generic. So I know that the distance here is basically the distance from the origin to x2. The distance here is the origin to x1, and I can subtract those. And I get this distance. So I take the x2 minus the x1, and I get that distance. Now notice, I am strictly talking about distance. I am not talking about direction. It doesn't really matter if I'm talking about 2 points over here. The distance would actually be the same. The distance between your house and work is the same as work to your house. We're not talking about direction, we're strictly talking about distance. So distance itself is actually an absolute value of a difference. So we have to be a little bit careful about that, okay? It is actually an absolute value. Because again, we're not talking about any direction. It can't be negative. We can't have a negative distance, just like we can't have a negative length, okay? Distance is like a length. Now then, if I were to look at 2 points on my graph, this point and this point. So I'm just going to call this C and D. And I want to know the distance between these 2 points. Well, I don't have just an x1 and an x2 anymore. I have an x difference and a y difference. What I can do is I can create a right triangle. And now I have an x1 and an x2, and then I have a y1 and a y2. And I have the differences. So I have this distance and this distance. I'm wanting to find this distance over here. So I'm wanting to find this area. Okay? Remember with Pythagorean theorem, it's leg squared plus leg squared equals hypotenuse squared. Or we said the distance, in this case from C to D, is going to be the square root of the absolute value of x2 minus x1 squared, because it's this one, plus this one. So plus y2 minus y1 squared. Now again, it doesn't matter if I go x2 minus x1 or x1 minus x2. They're going to give me the same distance because I'm looking at absolute value. And that will give me the amount, the length from here to here. So our distance formula can be written two separate ways. And you'll see me write it d of AB, because we're talking about points A and B. D just meaning distance. And we have x1, y1, x2, y2. Now the x1, y1 means it's coming from the first point, and x2, y2 means it's coming from the second point. So be careful about that. I'm going to take x2 minus x1 squared plus y2 minus y1 squared, and I'm going to take the square root of that. You'll notice I changed the absolute value signs into just parentheses. Why did I do that? Because in all honesty, when you take a negative value and you square it, it's going to become positive. Remember, negative times negative becomes positive. So I can leave off those absolute value signs because once I square it, it's going to become positive anyway. So whenever I solve, I should have a positive number plus a positive number. And then I take the square root of that positive number. After you square, you should never have negative numbers left. Remember, it does not matter if I do it this way or if I do it x1 minus x2 squared plus y1 minus y2 squared and take the square root. You will get the exact same answer. Distance has no direction. You're just going a different direction to get those values. It's like I'm going from this direction to this direction versus this direction to this direction. That distance is still the exact same. That difference type of thing. It doesn't matter, okay? You'll see it written both ways. So let's see and look at finding the distance between these 2 points. Negative 2, 1 and 5, 4. So I'm going to say that this is x1, y1, just because it comes from the first point. And then we have x2, y2, because it comes from the second point. And I want to find the distance. And that's going to be, I'm going to start out with doing the x2 minus x1. So I'm going to take 5. And you'll kind of notice where I'm changing the colors. And I want you to pay attention to that because I'm going to do 5 minus a negative 2 squared plus a 4 minus a 1 squared and take the square root. So you'll notice where I put all the green is from the original formula. Square root, this minus sign, square, this plus sign, this minus sign, the square. Okay? The blue is coming from this second point over here. The red is coming from this first point. So you'll notice blue comes first, red is second. Okay? Now I will solve. 5 minus a negative 2. Minus a negative becomes plus, so that's going to become plus a 2 squared. And then we have 4 minus 1 squared. I'm going to take the square root of that. Remember that square root cannot just drop off or cancel those squares. So I have 5 plus 2, which is 7 squared. 4 minus 1 is 3 squared. 7 squared is 49. 3 squared is 9. 49 plus 9 is 58. So I have the square root of 58. Now let me show you if I switch to D1 minus D2. Does it make a difference? So I'm going to do negative 2 minus 5 squared plus 1, let's see here, minus a 4. And that's going to be squared, and I'm going to take the square root. Okay, so I have the distance is equal to negative 2 minus 5. So negative 2 minus 5 will give me a negative 7 squared. 1 minus 4 will give me a negative 3 squared. Negative 7 times a negative 7 will give me a positive 49. Negative 3 times a negative 3 will give me a positive 9. 49 plus 9 will give me a 58. I get the exact same answer. So you just have to pay attention, making sure that the values come first, come from the same point, the values second come from the same point, and that you square both, and wherever you square, that you get positive values. And so practice some of the distance formula.